As mentioned, my name is Gustavo da Silva and I am the intake system engineer for this year's Formula SAE team. I'd like to begin with a brief explanation of the induction system and its associated components. The purpose for the induction system is to direct the airflow into the engine. This does this by means of an air filter, usually made of cotton or foam. This then goes through a throttle body, which regulates the airflow into the engine and is modulated by the driver. Formula SAE requires a restrictor with a 20mm orifice, which has been implemented. This then feeds into the plenum, which usually incorporates velocity stacks at the beginning of the runners and goes straight into the engine. The injectors are generally installed at the flanges, which is part of the intake manifold, allowing the intake manifold to be secured to the engine. The goals for this year's intake system are to, firstly, meet the early completion deadlines. This will enable us to get the engine on the dyno for extensive tuning, netting a very efficient design or a very efficient tuning system, very reliable, and with our desired power curves. We also need to solve fitment issues that were encountered in last year's design. Formula SAE requires that a tangent line from the top of the roll hoop to the rear wheel, either wheel, and the back of the car, nothing be in the way of that. Last year's design had the TPS sensor bracketry in the way, so we need to solve that fitment issue. Then we need to ensure that the overall flow is adequate, hopefully reducing cylinder starvation and maybe increasing performance and the reliability. CSUN has explored a vertical style design intake manifold. This incorporates a straight through plenum with a restrictor. Velocity stacks are usually inside. Usually equal airflow to all cylinders is associated with this type of design when designed properly, and it incorporates very complex geometries. Some of the pros and cons associated with a vertical design would be, on the pro side, it effectively solves our clearance issues. It can be a very efficient design, as mentioned, with equal length runners aiding to our performance. However, on the con side, it has a very complex geometries which are great for performance, but very time consuming and difficult to manufacture, therefore becoming an expensive endeavor. This may also incorporate bends in the runners, hindering some of the performance gains. And high turbulence may also be present due to poor design. Another successfully implemented design in previous years would be a log style cylindrical plenum design. It's been proven to work and is very reliable. It's made of carbon fiber, manufacturing is simple, reducing our time of manufacturing, and it's an efficient design when cylinder starvation has been taken care of and properly dealt with. Having a relatively simple design facilitates manufacturing in lighter weight materials like carbon fiber and possibly improving performance, efficiency, and reliability. Log design also has its pros and cons. On the con side, we have a clearance issue that needs to be addressed. Cylinder starvation is present due to the aluminum construction having sharp angles and uneven flow characteristics, mainly the cylinder starvation, and the aluminum is heavier than carbon fiber. However, on the other hand, it is easier to manufacture, leading into faster manufacturing time, in turn reducing our costs. The proven reliability and efficiency almost guarantees performance and trouble-free operation, which is crucial to our endurance race. Along with the tremendous tuning time gain, yielding a highly tuned, smooth, reliable engine system, perfect for our dynamic events. This brings us to our proposed design. We will be using a log-style intake manifold constructed in aluminum due to its mentioned proven reliability. The manufacturing time is very low thanks to a relatively simple design, and its low cost reflects the availability of the material. Having said that, I will be exploring in parallel with the proposed design the feasibility of implementing a carbon fiber intake system. This is a design which was attempted last year. This design was thoroughly analyzed, developed, making it into the manufacturing stages. This manifold showed reduction in cylinder starvation, improved flow characteristics and performance. The lighter weight material also improved performance by increasing the power to weight ratio. The design was never completed, however, due to structural and surface problems on the inside of the intake manifold on the final stages of in-house manufacturing. The key thing right here would be the donated labor and materials, which have already been sourced courtesy of highly recommended HDM composites. Thank you very much. This concludes the intake system overview, and I'd like to introduce Sri, who will be speaking to you about the exhaust system.
Hello everybody, my name is Sri Prajapati and working on the Exhaust 2009 Formula SAE competition. And here is the purpose for the exhaust system. The purpose of the exhaust system is to efficiently remove the burn gases from the cylinder and throw to the environment. Another is to keep the velocity of expelled gases very high so that we can have the scavenging effect and we can create the vacuum so that fresh charge can come inside and we can optimize the engine performance. To silence down the pulsation of the engine and to create the right amount of back pressure to produce the desired amount of torque and power. That is a key factor. So goals for 2009 Formula SAE for exhaust system is to facilitate the smooth routing and maximize the scavenging and leaving the velocity of expelled gases very high, reduce the back pressure of the engine, increase the drivability and optimize the power and torque, which is the winning factor, and the exhaust system, tune the exhaust system to optimize the performance. That's the goal for 2009 FSAE exhaust system. Let's see how the previous designs were for the exhaust system. The previous designs has the headers made of the mild steels. They have a 4-to-1 collector package for the mild steel, single exhaust system. For the mild steel, they purchased the muffler, and the only thing I found is the lack of smooth routing, and which we are working on this year. So the design options we have for 2009 Formula SAE competition for exhaust system is we can use the headers or manifolds, we can use the single versus dual exhaust, we can use the collector package, 4-to-1 collector package or 4-1 collector package, depends on the applications. We can incorporate the crossroad pipes and the materials. So let's say the headers or manifolds, what should be used? Headers facilitate the scavenging. That means the burn gases from the cylinder can easily go away to the environment and we can optimize the engine efficiency and we can burn the full charge entering into it. So it increases the engine performance like that. Intelligent use of headers may reduce the tubing, and just problem is just a little complex manufacturing than the manifold. While the manifold is very easy to manifold and it is very suppressive to the exhaust flow, that is not good for our application. It has extensive back pressure and reduce the engine efficiency, and the main factor we are not using the manifold is because it does not utilizing the scavenging effect, which is the key factor for the good engine performance. So single exhaust or double exhaust. Of course the double exhaust is very good as it has a double tubing, but lowest back pressure, increase the exhaust flow, but it has a more tubing, double up the cost, double up the weight, double up the manufacturing time. So, and the critical problem is its packaging problem. We have to fit with accommodate that with the suspension systems. So we are not using the dual exhaust system, but we are using the single exhaust system. Even though it has a low decrease the exhaust flow compared to the dual exhaust flow, and it has a more back pressure. So we are working to reduce the back pressure. So single exhaust system will work according to our application.